Hey everyone and welcome. Today we're going to dive into something amazing, the super fast network inside your own body that lets you think, feel, and react to absolutely everything. Ready to see how it all works? Let's get into it. So, let me ask you a question. How fast are you really? I mean, how quickly can your body react when something happens? Well, believe it or not, you can actually find out with a really simple test, and we're going to look at exactly how it's done. And that leads us straight to our first part. A fun little experiment called the ruler drop test. It's the perfect way to see your body's communication system in action. Okay, so this test is super simple. All you need is a friend and a ruler. One person holds the ruler up high, and the other person gets their fingers ready at the bottom. Then, without any warning, it gets dropped. Your job is to catch it as fast as you can. The trick is to see how far it fell before you grabbed it. The shorter the distance, the faster your reaction time. It's that easy.
That little measurement, that distance, is what we call reaction time. It's basically the tiny delay between the moment your brain senses something, like your eyes seeing the ruler fall, and the moment you actually start to move in response, like your fingers closing.
But that brings up a huge question, right? Why isn't it instant? Why is there any delay at all? What is actually happening in that split second between seeing the ruler drop and catching it? Well, that little gap, that's where our story really gets interesting. So, what is going on in that moment? To figure that out, we need to meet the incredible system that's responsible for sending every single message throughout your entire body. And here it is, the nervous system. This is the master control center for your whole body. Seriously, think of it like your body's own private internet, a communication network that controls absolutely everything you do. Now, this whole system is basically split into two main teams. First, you've got the central nervous system, or CNS. That's your brain and your spinal cord. These are the decision makers. Then you have the peripheral nervous system, or PNS. That's all the other nerves spreading out through your body. They're the messengers, carrying info to and from the decision makers. And these messengers, well, they have two very different jobs. You have sensory nerves, which carry messages in from your senses, like your eyes and skin, to the CNS. And then you have motor nerves, which carry commands out from the CNS to your muscles. It's like a one-way street. Information only flows in a single direction on each type of nerve. So let's trace the signal's path during that ruler test. First, your eyes sense the ruler's falling. Instantly, that signal has to travel all the way up your sensory nerves to your brain. Your brain then has to decide what to do, and finally, it sends a command to act, which travels down your motor nerves to your hand muscles. That's the delay. The message has to make that entire round trip. Okay, so let's zoom in a little bit on that decide step. We're going to go inside the main control center itself, the brain. This is where all the big calls are made. You know, I love this quote because it just says it all. The brain is the boss. It's working 24/7, managing everything from solving homework problems to making your heart beat, even when you're fast asleep and dreaming. And the brain kind of works like a team, with different parts having their own special jobs. You've got the cerebrum, which is in charge of thinking and any movement you choose to make, like solving a math problem. Then there's the cerebellum. That handles balance and coordination, which is why you can ride a bike. And the brainstem? It takes care of all the automatic jobs, the stuff you never think about, like breathing. But what if you're in danger? What if you need to react even faster than that? Well, for emergencies, your body has this amazing built-in shortcut, and it's called a reflex. Okay, picture this. You accidentally touch something really hot. Ouch! The sensory nerves in your skin send an urgent message. But here's the cool part. It doesn't go all the way to the brain. It takes a shortcut straight to the spinal cord. And the spinal cord doesn't wait. It immediately sends a command back to your muscles to pull your hand away. It's only after your hand is already safe that the message finally gets to your brain and you think, whoa, that was hot. So that's a reflex. It's a fast, automatic response that you don't even control. It's basically your nervous system's ultimate safety feature, and its whole job is to protect you from getting hurt before you even have time to think about it. So we've seen just how fast this system can be, both for regular actions and for those super fast reflexes. But why does all this speed matter in our everyday lives? Let's take a look. Well, who needs quick reactions? A lot of people. Think about athletes, like a hockey goalie blocking a puck, or a sprinter at the start of a race. Or drivers and pilots, who needed to stay safe. Emergency workers, firefighters, doctors, they use it to save lives. And you need it all the time for simple things, like catching a glass that's about to fall off the table.
All right, get ready for a number that's just going to blow your mind. That right there is the estimated number of nerve cells you have in your body. Over 100 billion? That's more than the number of stars in our entire galaxy. Just wow.
And if that wasn't crazy enough, check this out. If you could take all of those nerves and lay them out end to end, they would stretch for about 150,000 kilometers. To give you an idea of how far that is, that's long enough to wrap around the entire planet Earth almost 4 times. So when you really think about it, your nervous system is this unbelievably huge and complex network, and it's working nonstop, 24/7, to keep you safe and let you experience the world. And that leaves us with one last thought. It does so much to protect you. What can you do to help protect it?